So, just to give a quick backstory on North Star itself. So, North Star started in around the summer of, I believe, 2018 when Leap Motion originally announced it on their website. And it was a project they started to explore hand interaction in AR, since none of the headsets at the time had an affordable price or a wide enough field of view to really allow for high fidelity hand tracking. So what they ended up doing was building a custom solution using VR displays. So the North Star currently uses the same displays that are in the Valve Index, which are the BOE 3.5 inch. They can go up to 120 hertz, really bright, so they're pretty great for VR, and they work pretty well for the form factor of North Star. Unfortunately, at the time, they really didn't offer any kits or anything. So all the people wanted to build them. No one knew how. The reflectors were built with diamonds turning, which is, as you can imagine, very expensive. So, we were, as a community, we're like figuring out like, okay, like how do we build this thing, right? We had people 3D printing resin lenses, which I might have around here somewhere, but it looks like I've misplaced those. And we had people doing some vacuum forming and just trying to figure out different ways of building the optics. And then there was also like display sourcing. And if you're just a guy from the internet, you can't really go to China and just buy a display panel and a driver board. They don't really exist like that. It's not like buying a monitor. So all of those had to be sourced, and that was very difficult at the time for us. So this was before Noah and Combined Reality got involved, and we really had no way of building a headset. So the first one that was actually working outside of Leap Motion ended up using some Raspberry Pi displays, and that had pretty low resolution. It was like 320 by 640 per eye. The refresh rate wasn't great, and the lenses were 3D printed with like tape reflectors on them, so it was definitely a bit hacky. After that, I sort of experimented with taking apart a Samsung Odyssey and building that into a North Star. So this is my first one that actually worked. So these are all of the internals from a Samsung Odyssey headset that I took apart and then rebuilt into a North Star, which was pretty crazy at the time. I never got this fully working, but I do hope to get it, at least software-wise, working on Monado on Linux, which is super exciting. And I'm sure we'll be talking about that a bit later today. So obviously the headset has come a long way from a bunch of dangling wires and hacked displays to a more somewhat polished product. So this is our current iteration of the headset. This uses a Leap Motion controller, a RealSense T261. We've got a custom driver board in there that we've manufactured and sourced. These are the official displays from Leap Motion, the BOE 3.5 inch 120 hertz displays. We've got a custom USB hub on there that reduces the need of cables to just two for now, so one for power and data and another for display. And we are looking at completely redoing the display subsystems to allow for a single cable to be used in some circumstances. Um, so that should be super exciting. And if you want to see more about that, you can check out the Deck X channel on Discord. We've been posting some of the diagrams and early thoughts there. So if anyone here has a background in electrical engineering and wants to give some thoughts, that would be great. We are definitely looking for some more contributors there. Um, in the meantime, sort of moving forward and talking about our future plans. So we are looking to do a Kickstarter. We are currently tentatively planning this for the end of July, but this might vary based on the current chip shortages in the world. There are quite a lot of things going on there that are making it a bit hard for us to manufacture things, and it is why the display drivers are currently out of stock, though we are working on getting at least a few hundred of them back in stock. We were able to supply or get a supply of some more chips. We just have to be careful about how we manage that since they're pretty much non-existent right now. Um, Moving forward, though, we are looking to do a few major advancements to North Star itself. The first is we're partnering with Luxonis, which is the company that makes Depth AI, which is a essentially Intel Myriad X based camera API that allows you to do machine learning and everything on chip. So right now we're using the Intel RealSense sensor. While that's great, it has a few drawbacks. One is we can't really control the amount of cameras we have on it or what the machine learning is doing, right? So it's essentially a black box that we get slam out of, which is really useful, but it's not really the best for an open source project. So what's great about the Luxonis system, I'll bring this a bit closer to the camera so y'all can see. This is a prototype that we're working on right now. This has a OmniVision cameras for each one. So these two are monochrome on the edges, and then we're experimenting with different RGB cameras for the middle. The RGB cameras will be useful for mesh reconstruction and scene reconstruction, and the monochromes are going to be great for high frame rate SLAM tracking. And we do have a partner that we're not ready to announce yet that is working with us on getting some very, very high quality SLAM running on this headset. So we're super jazzed about that. And these cameras will just help us a lot. So not only do they run higher frame rate than the RealSense does right now, which is about 30 hertz for cameras, these run at 120 hertz. These are also higher resolution and will allow us to do some more advanced configs in the future, which is super duper exciting. And of course, these aren't the final form factor at all. These are all prototypes for the final headset that we'll be launching in July, hopefully. Fingers crossed. So that's sort of the advancements as far as cameras go. We are also going to be integrating the Rigel sensor, which is the very small leap motion here, into our headset, which will reduce the size quite a bit as well. So with that combined with the Luxonis cameras, we're pretty excited about the next generation of Northstar. I think it'll be a huge step up from the current system in terms of form factor and in terms of fidelity as well, as both camera systems we're using are upgrades over the existing sensors. So that sort of goes over the state of Northstar now and where we're looking to take it. As far as software goes, I will walk through that a little bit now. So there are a few software platforms that we support. On Windows, we have ASCII, which is our Australian based Unity and Unreal system. So right now we're working towards figuring out the path we want to move forward toward with OpenXR on Windows. We are looking at porting the Monado runtime for Linux to Windows, or at least assisting with that, and getting that on Northstar. So essentially on Windows, we have a full OpenXR stack. On Linux, we actually already have that supported, everything up until the latest leap motion for that, which is currently the second gen software, but we are in talks with Ultraleap about getting Linux support. I don't have anything else I can add there for Linux, but we do have a full Linux stack, which is super exciting for OpenXR. We are moving towards that on Windows. Right now, our Windows support is primarily based on ASCII, which I said, which is our custom subsystem, and then we've also got some beta SteamVR support built in for both of our calibration methods, which are both pretty well supported in that system. But we do need more beta testers for SteamVR. So if anyone here happens to have a headset, I know they've been out of stock for a while, it would be great if you could run through that and test it for us. And yeah, I mean, so the one system that we don't support right now as far as OS is Mac OS, and that is mostly because Macs haven't had great graphics chips for a long time, and running anything graphically intensive on the Mac usually overheats it. Though with the M1 chips, I am super excited about those and seeing the possibilities there. So what I would like to open it up to now, I know it is a bit early for Q&A, but I would love to hear from all of you about what you want to do with Northstar and what has you interested in the project. A good text channel to chat about the summit. I will actually just make one right now in voice for this. So I'm going to call it Summit, and it is now in voice. So there we go, instant feedback. So yeah, so I would love to hear a bunch of questions on that, and you guys can post them in Summit or ask them here. Unfortunately, we weren't able to use the Discord stage feature for this event because they don't allow video or screen shares for this, which is kind of lame, but we'll do our best with the voice channel here. So what I'll have y'all do is if you can just give me the raised hand emoji and I will go one by one and answer or allow you to ask your questions in voice. WebXR on Linux, that is a great question. It is supported right now, actually. WebKit just got WebXR support and we have run it in Monado. Sam, if you can grab Moses's video from either Twitter or the Discord and post it in the Summit channel, that would be great. But it is super duper exciting to be able to have full WebXR support on Linux. It's pretty great. One of the things we're looking at improving right now is the setup time on Linux. Obviously, Linux people love tinkering, and right now that's sort of what you have to do to get Northstar running on there. There's a lot of sudo commands to install and things to get up and running for web, especially for Monado and WebKit. It's not the most straightforward thing, so we would love to have a package for that you can download just like you would Slack on Linux is sort of my personal goal is to make the time to development shorter and shorter. So great. We break 2 LCDs already. That's no good. Um, but yeah, so speaking towards that, actually, we are working on making the headset easier to build. One of the things we've had to do for a while now is actually the ribbon cables on the displays that we buy do come with the ribbon cable glued to the back of the display. We recently launched display cable extensions, which are custom, that will allow you to no longer have to do that, which is pretty exciting. So it'll make the headset definitely easier. The only problem is that that happened right at the time when they went out of stock. So not many people have gotten to have that chance yet. So yeah. And thank you for letting me know, Sam. You were great. Yep. Ideally, that is correct. No, that is ideally as easy as a single command or a single button push from like the Ubuntu App Store. Um, yep. Sam is the official full-time linker now. So that is wonderful. Um, all right. I am going to keep tabs on the Summit channel. If anyone has something they would like to discuss via voice, now is the time. So feel free to unmute and ask questions there as well. It's great, Sam. Thank you. Um, Yeah, so really, like, I would love this to sort of be more of like a roundtable kind of discussion here about what the future of open source augmented reality could hold. I know there's a lot of questions with regards to privacy and how we filter that out. So, that would be a great discussion as well. I think there have been a few papers from Microsoft actually on environment-based privacy reconstruction, as there are a multitude of, having a camera on your face is, an inherent privacy risk. So there are a few systems we're working on as far as obscuring that goes. The benefit of having a depth AI system here is that we can essentially do or try to do most of all the processing on the chip here, so that the only data that we can send through back to the host is the position and rotation of the headset. And we can allow apps to request different different settings there, right? So, if your app wants to request spatial reconstruction or access to the camera feed for some Snapchat-like filters, we can have that on a per user basis, which will be pretty great. But that's something that's definitely still in R&D, at least right now. But it's definitely something we want to sort of move towards is more of Linux as an OS for the North Star. And one of the things actually I haven't touched on yet is the compute pack systems. So, obviously having a headset is great. Having a standalone headset that's not tethered to your computer is better. So one of the things we've been experimenting with, and this is a very early prototype, so it will be much thinner than this. This is an AMD Ryzen V1000 chip. We are looking at using the V2000 or Ryzen 4800U chips for our final launch. That is still to be determined. We're also investigating the Intel Xe graphics as well, as those are also pretty well performant. So the main benefit of using one of these is you can have this clipped to your belt, similar to the Magic Leap Compute Pack, and have a full standalone experience with augmented reality, which is really exciting. Yeah. So yeah, so that's we're super excited about that as well. Those will be an optional add-on for our Kickstarter. So the way we're going to sort of structure it is you're going to be able to buy the headset or buy the headset with a compute pack or buy like 7 headsets if you want to pay the same price as a HoloLens. So that'll be super exciting. We don't have full pricing yet just because we are still manufacturing some things and figuring out the bill of material cost on everything, but we are aiming to have it be very affordable. Essentially, we're taking incredibly low margins on it in the benefit of getting headsets into everyone's hands for a reasonable price and having people develop things on them. So yeah, how long before the new display for boards and drivers mentioned will become available? Holding my breath for a couple months. Yeah, so we are working on it. If you check the DeckX channel, you'll see the diagrams for the new boards we are working on. There's definitely been a lot of delays recently due to the worldwide chip shortages. And to combat that, we are actually building a fully modular display subsystem. And what this means is that the actual chip that will be driving the displays, which has in the past been an Analogic 7530, Moving on, it will be a chip from a company called Lontium for now, and the goal is to be able to have that on an M.2 card, just like you would an SSD for a laptop, and essentially switch out the chip whenever you want. So we'll have a single carrier board, and you can drop in the display driver chip, which will allow you to essentially upgrade your headset over time, which is pretty wonderful. And then also, not only that, but it'll also allow us flexibility in the manufacturing of these boards. As far as time goes, like I said, we've announced the Kickstarter date, so if they're not ready before then, we're going to have to push that back a bit. Um, so I don't recall the exact name for the display driver chip. It's kind of like if you know those, like when you hear a new gaming company has released a monitor, it's like the LG X7072 XYZ. It's kind of like that, but it is from a company called Lontium, and I believe the specifications are in our Dex channel. Sam, if you can find them from Noah and link them, that would be wonderful. Um, so but it is a DisplayPort 1.2 chip right now that we're sort of looking at, which will limit us to 90 hertz at the moment. We're hoping we can eke out 110 hertz, but due to the amount of bandwidth we're trying to push over a single cable right now, it may not be. So that's still a little bit up in the air, but we will keep everyone updated. And of course, we're going to be as transparent as possible with our Kickstarter. So it will be like the Raspberry Pi Compute Kit. Yeah, that's sort of a similar style. Um, so, the goal is to have a headset that not only can be upgraded in the future with different display panels or different driver boards, but also have one that allows us to keep the most manufacturing freedom as possible. Right now, just given the severity of the chip shortage, there is we want to make sure that our system is as free, updatable, open source, and we want to make sure we're nimble enough so that way, if something else happens with our supply chain, we can move off of something really quickly and onto another solution. But yeah, I would love to open it up to questions again. So I'm sure y'all have them. I know it. I can sense it. Yeah. Happy to answer any software questions too. I know we've been talking a lot about hardware right now, but software is definitely important, and I can go through a bit about ESCI and our current Windows framework if y'all want that as well. So right now, obviously, with the any kind of headset, there's a lot of software involved running it. There's tons and tons of code on the Oculus runtime and the SteamVR runtime, and Vive has their new one. Would now be a good time to talk about the longer term vision for a fully open hardware and software stack? Absolutely. Yeah, it's never a bad time to talk about that. Yeah, I think there is a lot of discussion there. And I think one of the things that it can depend on, Trevor, is like, what do we consider fully open source, right? Because with any kind of headset with this level of technology in it, at least some of the components are going to be closed source. For example, even though we can put an Analogix IC on the board, it doesn't mean that component entirely is open source, right? So I think like really what we're trying to do now is be as open source as possible and be as modular as possible. So if people want to run whatever software they want, they can or cannot. Absolutely. Yeah, let me click on that link, and I'll do a screen share as well, because I think your work on trustworthy AR glasses is absolutely wonderful. So I will pull that up and start a screen share for that. Let me just, all right. So I'm gonna keep tabs on Summits. Yeah, that'd be great, Trevor, if you want to do that. That's absolutely wonderful. Yeah, more than happy to have you on with me.
See which camera I'm actually looking at. Hello, everyone. Hey, Bryan.
Hey.
I mean, the summary of that page, there's a lot of text on that page. It definitely is not worth reading on the channel. But the summary of that page is basically how do we work towards a time when manufacturers of every component, so chips on up, are using open specs such that multiple manufacturers can create it, that they're designed to be verified by third parties so that when you get a chip from someone, it can in some way be verified. I know that Bunny Huang's team has a whole set of hardware hacks that they have around sealing FPGAs and other things like that that help you sort of know this is the actual configuration of the chip description. That is the one I actually want. And then the last thing is basically just a community around it, so that if you want to take hardware from someone and put a different software stack on it, then you don't have to ask for anybody for keys for that. And those are obviously like radically different than the way we build things now in general. And so my work,
Absolutely. Like,
yeah,
one of the problems I had with this guy is I couldn't change the edit on it, right?
right.
And for those who don't know, the edit is a essentially it's called the of course I can't remember the name now. Essentially, it's the little bits of code that tell Windows or Linux what your monitor actually is, right? So they send like the resolution, the frame timing, and in this case, there was a very specific byte on the second table of the EDID that told Windows this was a Windows mixed reality headset. And I was like, nah, I want it to be a screen, y'all. Can I have it be a screen? And they said no. Um, but it's like that kind of stuff that's like you can't flash it unless you have the key for the device itself. And that's something that's unique about Northstar is that because all this hardware is open, you can essentially do whatever you want to it, good or bad.
Yeah, I mean, so, but the the Ultra Leap hardware, for very good reasons, commercially and sort of systemically, there are closed blobs that they we
Yes.
can't flash over and things like that. And I'm
Right.
definitely not the kind of person that says we can't use that stuff right now, and it's it's the end of the world if we can't. But I do think that it's worth thinking about as a community. What are the pieces we can work on today to get towards this sort of end goal of actually trustworthy AR gear? Um,
Absolutely.
yeah,
Yeah, and I guess like a question for that would be like, if anything, like obviously, that is a great point that sometimes I forget that the Leap Motion software is closed source and it is a binary blob. Um, and for good reason, obviously, because they've spent millions and millions of dollars developing this software, and it is the best hand tracking on the market right now. But does it mean that anything like how can we make a closed binary blob trustworthy, right? Or are they inherently untrustworthy, right?
I mean, my general take on it is that they are inherently trustworthy, and obviously, trust is not binary. If you know the people that work there and you're good friends with them and they have a great track record, that's a very different story than if it's a random blob you got from a stranger somewhere on the net.
Right.
And so um, the goal that I have is kind of a binary goal. It either is totally transparent and inspectable and verifiable, or it's not. But I think there's definitely middle ground in the meantime, if nothing else, where we trust someone to go in and do a verification of the software, and then they're not allowed to share what they saw, kind of thing. I know that not a lot of software companies have they will open themselves up for verification by third parties, even though the software is not actually shared with anyone. But they'll depend on someone coming in who's trusted by the community to then do a review and say that it has these characteristics. So that's one of the intermediary grounds that I've definitely seen people suggest that I think might work for us as a community until we get to the far-reaching goal of
Right.
total
Yeah, I
open
mean,
transparency.
I think one of the other things to look at, and something I've been thinking about for a while that I want to bring up here, actually, it's great that we have a whole bunch of people here to discuss this, is the idea of Project Start as a foundation. Now, what I've been wanting to set up for a while, I haven't quite figured out a way to profitability here, right? Essentially, I want to set up what Blender has for open source 3D for open source AR hardware and software. And this essentially means being able to pay developers, being able to hire people, and being able to have people work on this without having a direct investor model, right? Because of course, we could go to Silicon Valley investors and be like, "Yo, give us millions of dollars. We're gonna make an AR headset, y'all." And then of course, we'd essentially be selling out, and the company would then be driven by other interests. One of the things that's great about Northstar right now is that it is a community-driven model, driven by people who are volunteering and donating their time and effort and money in the case of what Noah's been doing and essentially self-funding this project for a few years, which is, incredible. We're really banking on the Kickstarter being successful, so that way we can move away from him just spending his savings on this. But that's definitely a one way of moving forward. But we would love to actually be able to hire people, and we've been very fortunate that Collabora have been willing to build out Nano, which is open source XR run open source OpenXR runtime for Linux. That's been a great tool for us to use and experiment with. And we've got Northstar on there, and they've been very helpful in getting that working. But I would love to be able to say pay Michael Boone, who's been working on SteamVR for us, to actually work on SteamVR at least part time. And right now, all of that work, including all of the work I've done, has been almost completely voluntary. So building a system where we can figure out if we want either companies to, essentially give us grants, similar to Godot or Blender, I think would be really great. And it's just going to take a lot of work to set that up. So I would love if anyone has ideas on structures for that, or anything they would want to see from a foundation or organization like that, whether it be custom software or custom hardware here. That would be great to hear as well. I'm just going to check the Summit chat real quick as I see there's some messages there. Yeah, fully shared source, fully shared manufacturing, absolutely. And I think at least right now, given the state of the industry, that we want Northstar to be a competitive um, headset with the things that are out there, like the HoloLens and the Magic Leap. There will be, at least right now, some form of closed source componentry to it, just because of the cutting edge nature of the product. Um, like while the Depth AI platform is open source, the actual MyriadX translation layer is closed source, since that's Luxonis's business model, and the Leap Motion Sensor obviously is also closed source component. But the idea, at least for the platform, is to have the headset. You don't have to use a Leap Motion if you don't want to, right? So if you want to use, say, Collabora's new OpenXR hand tracking system they're developing for Linux, you would be able to use that. We wouldn't force you to use the Leap Motion. In fact, you could even open up the device, unplug the Leap Motion, and everything would still function normally, provided you provide your own hand tracking subsystem for that. So
I think that's
the goal
amazing.
is to really provide freedom. We would love to continue the relationship we have with Ultraleap. They've been incredibly helpful in not only their software support with the Unity interaction toolkit they have, which they've also open sourced, by the way. That is now under Apache 2.0, which is pretty wonderful. So they've definitely been great stewards in this space. And one of the reasons we're still sticking with the Leap Motion sensors is because they did open source this project in the first place. And if we were to take their project and say yeet out the Leap Motion and put in our own system, what does that say? What does that say to other companies who are looking to do something similar, right? There's so much R&D that happens at companies like NVIDIA or Intel or even Magic Leap and Microsoft that has the potential to be open source because they're not using it. And that would be absolutely wonderful for this kind of community. So we want to show that, like, hey, if your company wants to put this stuff out there, we're going to work with you on keeping this platform open and making sure that the effort that you all put into this project is going to be reconstituted in this case the form of people who are going to be since we are selling Leap Motion sensors with the headset, obviously they are making some form of profit off of this product. So
I definitely see a model where we work with hardware manufacturers, and yeah, for some period of time, we agree to pay for what is not yet a commodity. So SLAM is becoming, the SLAM algorithms that are open source and coming out of academia are getting better and better, and eventually SLAM will be a commodity. And so, same with ham tracking. Obviously, there's years involved where the open source stuff is not as good as what you can get from the companies that pour millions of dollars into R&D. And so I agree. being careful with manufacturers to be clear that we're not out to take their special sauce, but we are out to make all the things that are at some point common goods
Absolutely. I
available
think,
for free, in an
yeah,
easy
like
way.
if you look at the Z Mini, for example, is a great case where they solved a particular problem but didn't have a full platform to showcase the solution for that. They were literally taping the Z Mini to the front of an Oculus or the front of a Vive. And same with Leap Motion for a long time. They had the little plastic thing you would 3D print onto your headset, and then you were playing with the hands, you would just knock it off and start, it wasn't the best integrated solution. So if we can provide that solution for those companies, I think that would be absolutely wonderful. In that, hey, we see that like Leap Motion has hand tracking and Zed has spatial tracking and spatial meshing. If y'all want a platform for that to showcase it in the best light, especially for augmented reality, we've got that. And one of the other things too, is like since these components are the same as virtual reality, there's no reason why we can't port this to a virtual reality system as well, right? Same screens. The only thing we would need to change is the configuration and the Fresnel lenses, of course. So, I think there's definitely potential there. We've just been trying to stay focused on a single project at the moment. Um, yeah, and I think as far as operating system goes, I think if we can have either the compute packs, like ideally it's the user's choice, right? Uh, If if you want to run um, Linux or if you want to run Windows or Mac OS or whatever, that should be the choice of the user who bought the headset, right? We're not going to force anything on them, and it would be a mistake too, right? There are things you can do on Windows that are absolutely excellent that you can't do on Linux right now, and vice versa. There's things you can do on Linux that are just, it's a bit more friendly to development of specific things. So, and I do just want to take a little bit of a break here and just say thank you to Trevor for piping in there. That was absolutely wonderful conversation. So thank you so much. Um, and I think it's a balance between what we want to do with user choice and and also building out a system. If we do plan on building out a Linux-based operating system specifically for augmented reality, would we want, would that right now that would impact our ability to provide cross-platform support essentially due to our development stack at the moment and the resources we have to develop things. So there's definitely a lot of work there that can be done on improving that out and scoping it out for one thing, right? It's one thing to say, hey, we're going to build a full open source AR operating system. It's going to be sweet, yo. And it's another thing to scope it out and actually determine what features we need and build it. These problems that we're looking to solve, whether they be hardware or software, are not easy by any means. And I want to stress that, like, even though we've made, 3D printing that's. Oh, by the way, I didn't even mention that this thing's 3D printed, y'all. You can print it yourself. Most of the plastic components here are all 3D printed, save for the optical components, which right now 3D printed technology doesn't lend itself to. Um, I've always just assumed that this headset is like it's very clear that it's 3D printed for people, but I always forget that. Um, yeah, so I totally agree that it is not trivial to do a lot of this stuff, and we're hoping with the Kickstarter that we can provide injection molded pieces, which will make it one easier for us to manufacture, and two easier for people to build as the tolerances will be better. One of the biggest fights we've had to do so far is user-specific calibration files for every device, and especially with the pandemic right now. Originally, we were planning on shipping out calibration stands to a bunch of makerspaces and having people go to those to calibrate their headsets, and it would be like a big group activity and stuff. And unfortunately, the pandemic kind of derailed that to the point where we developed a new software that instead of using, a dual stereo calibration camera rig, you can use the RealSense camera that comes with your headset to calibrate it, which will allow you, at least in the meantime, to get a suitable calibration that you can use with your device and get up and running and have a good experience with Northstar itself. Um, so that being said, um, I would love to hear. I see that Fabian is here as well, which is wonderful. We had some great discussions about WebXR yesterday. I would love to hear what y'all want to see from this project, whether it be LiDAR sensors or some more advanced things. I think one of the things we haven't done quite yet, at least, is we have a pretty good idea for what we as a community want, and that's sort of why we're moving towards the RGB sensor on the Luxarnas module here. But we haven't really talked about LiDAR, flight sensors at all, and mostly because of the added cost of those, right? We want to keep Northstar affordable, of course, and those are typically like $30 to $40 just on the bill of materials, not including margins or anything. So, those kind of sensors can be a bit more expensive than just plain old cameras. But we would love to hear about any features or requests that y'all have. And eventually, obviously, we're using this version of the optics right now. But moving forward, as smaller displays become available, like micro LED and mini LED displays as well, we can definitely move to a more exotic display technology as those become available and further shrink the form factor of the headsets. So, yeah, let me just check the Summit channel here real quickly. All right. Yeah, so the new calibration is really cool. You can check that at docs.projectnorthstar.org, and there's a 2D calibration there, which essentially uses, if you've ever seen the projectors that will do like like almost like a barcode scan of your room and then figure out where the 3D is from there. That's essentially the same technology we use for optical calibration at the moment, which is really cool. So essentially, we're doing a mapping from the camera of the reflection of the optics, right? So if we have the screen here, camera here, we're essentially measuring the reflection based on the viewport of the camera, which tends to work out pretty well for us. Yeah. So, I think there's definitely a lot that we'll be discussing throughout today, but I will leave this open for any questions at the moment. I've talked quite a lot, and would love to hear y'all's feedback on this so far before we move into the next session. So, and I can continue talking. So if you all want that, I'll continue to do it until we move on. So let's see. We've talked about WebXR. We've talked about hardware, software, hand tracking, binary blobs. Trustworthy computing, which I think is incredibly important moving forward. I guess we can talk a bit about wireless technology, I guess. One of the things that I see as one of the biggest blockers right now for Northstar is that since we are pushing such a high resolution combined displays, it's 2880 by 1600. There's obviously a lot of pixels to push there, but then there's also camera data. So making that fully wireless isn't something that's feasible, and we've seen that with Quest, and they have some of the best minds right now in the industry at Facebook, and they've gotten wireless working, which is pretty incredible to be honest with you. But it's only on the display signal; they're not sending camera data back as well. And obviously, with the Snapdragon chip they have in there, it's definitely more power efficient than a Northstar would be. But yeah, there's definitely a lot that we could be doing in the future, and I'm glad to hear that some of y'all are enjoying the. So that's a great question, Alexander. So what technology would have to be improved for Northstar to be wireless? There are a few technologies that are pretty exciting. One is ultra wideband is an interesting technology in terms of proximity tracking. I don't think it's quite where it needs to be right now for full slam, but that would definitely be useful. And especially for detecting other devices as well and the general proximity of them. But realistically here, we would need to do on-device SLAM, which is simultaneous localization and mapping, and figuring out where the headset is, and all the position tracking would have to be done on headset. So that way we can send that over, either Bluetooth low energy or something like that to the host computer that's running it. And realistically, like just technically speaking, we need to add a battery to the headset so we can run that. We would also need to add some form of operating system to the headset so that it knows what to send and what to receive. So as far as Northstar goes that's a whole bunch right there. That's very complex. We do have temporal reprojection built into our main SDK right now, which would allow us to essentially receive frames from a computer and interpolate that based on the delay between the frames being sent and the frames being received on the headset. So the groundwork is being laid right now. It's just going to be quite a few years before the technology for that becomes available for us to use. And Wi-Fi 6 is definitely something that will benefit us, but you just need to keep in mind that there will be limitations that will be there, like line of sight and things like that, that will affect the fidelity of that experience. I don't want to be overhyping this at all. Like if you look at current Wi-Fi based wireless systems like the HTC Vive Pro, they have the big horn-like thing that you put on your head, and that's primarily because it needs a line of sight directly to the receiver in order for it to work. And specifically with the Vive, right? Especially the Vive Pro, which is running at the same resolution we are, albeit at a lower frame rate for now. There's like you have to plug in a full PCIe card just to get the bandwidth you need to send that kind of data wirelessly. So it's wireless is definitely not the way to go for right now, which is why we're looking at these compute packs here. But it's not something that's impossible, depending on what kind of experience you want and the fidelity of this experience that you're looking for. I think there will be some trade-offs there, but it's definitely something that's not entirely out of the range of impossibility. Um, yeah, so super exciting stuff. Definitely. Every day the industry improves and new things happen. That's actually a great question, Squirpeg. So, any plans for controller tracking? And I think Thaytan will go over this in his talk later, where he talks about reverse engineering the Oculus tracking systems. That's definitely work we can build off of, especially with Windows mixed reality controllers and other LED-based tracking systems. We're looking again with the Luxona system to really have the ability to do more advanced camera-based controller tracking. As far as right now, we need to sort of hold our priorities at on one thing and focus for a bit on the AR headset that is North Star. I think one of the problems that we could run into right now is just spreading our resources too thin and also developing controllers. We have really great hand tracking at the moment, and we are looking at primarily running that. Though there's definitely an ability to build an open source hand tracking, and I think that would be absolutely great for applications like augmented reality Beat Saber, which still suffers from hand tracking there. Um, the Pine phone and similarly Linux phone for a minimalist wireless compute unit. I would say maybe. It really depends on the graphics, honestly. So, open source things like that, like we've seen from PinePhone or other Linux-based subsystems, don't typically have great graphics. And unfortunately, for an AR headset, you need a great graphics chip. You need the ability to be able to push essentially 4K at 60 hertz. And that's just the display signal, right? So and most of the Linux systems struggle just to push those pixels, not to mention like triangles on top of that. So right now we are sort of limited to, I'd say the lowest end we can go is either Ryzen or Intel based x86 compute packs like this one. But it's definitely going to be something on our radar as far as subsystems to build there.